All right, we're going to pick back up with section 2.3 on our last two problems. There are a couple application problems that we have. So this is going to show how you can use the right triangle information that we've been looking at in this section for an actual physical problem. And right triangles are fabulous because you can use them in lots of applications. So I've chosen just a couple, and your book has a few others, of course, that you're going to take a look at, and a few more on my math lab. So the right triangle, it has a hypotenuse of length 8, and we have one angle of 35 degrees, and we're supposed to find the length of each leg. So the first thing we would like to do, of course, is to, well, draw a triangle so that we have a picture to go with this image. So I've got a right triangle over here I'm going to draw. And it told me that one angle is 35 degrees, so I can put that in either spot, actually, would be fine. That'll work. If that angle is 35 degrees, just so that we're all real clear, what's the other angle?
55.
55. Okay. Yep. In fact, 35 and 55, that's the one we just did on the board, actually, isn't it? And so we're supposed to find, oh, and it tells me the length of the hypotenuse is also 8, so this is an 8 over here. And we're supposed to find the other two sides. So let's find one of them. Let's just call this one X and this one Y. You can call them A and B, you can call them Q and W, it doesn't matter, just pick a letter. So let's find, so that we're all working on the same page, if I've lettered them this way, let's find side X first. So what trig function will relate this angle that's 35 degrees with this side that's an X and this side that's an 8? That is sine. So sine has the relationship that is the opposite, which is the X over here, over the hypotenuse, which is 8. And this sine is the sine of 35 degrees in this problem. Now 35 degrees is not one of those degrees that we worked with last time, right? What were those degrees? What were the special angles that we worked with? 30 and 60 and 45, right. So 35 is not one of those, right? Which means that in order to do this problem, you're going to need your calculator. So grab your calculator. How will I solve this equation as it is, though, right now for x? What do I need to do? Multiply by 8. All right, so I've got x equals 8 sine 35 degrees, making sure that your mode is set for degrees, since this is in degrees. And somebody's going to tell me what they get for 8 sine 35. It doesn't indicate how many decimals, so we'll just go with 2 decimal points. That's kind of my default on everything. So what do you get if you do 2 decimal points on this one? 4.59. 4.59? 4.59 what? Inches, yeah. Inches was up here in this problem, so we want to make sure that we use inches on our units as well. But I also need to find y, yeah? So how is my 35-degree angle, my y, and my 8 related? That's cosine. And we'll talk just a minute about another way we could think about this. But cosine of 35 degrees equals y, the adjacent side, over the hypotenuse 8. And I would do the exact same thing, multiply by 8. So y equals 8 cosine 35 degrees. And what is 8 cosine 35 degrees with 2 decimals? All right. Inches, right? Is there another way that you could think of that we could do this, the second part? Let's just talk about the second part. Instead of using the trig function cosine. You could use the Pythagorean theorem, right? You have to be a little bit careful if you use the Pythagorean theorem because we did round this 4.59, right? So you do need to be real careful that you don't lose some accuracy when you use rounded figures to find something else. How else could we find that value y? Okay, so you could do, I heard 2 different things, so let me tell you what Michael said first. I could use tangent, right? Because tangent would be using this side x, which I already found, which is 4.59, with this y. I could use tangent, but again, I'm using rounded figures, so I want to be careful if I do that I use the more exact figure of my calculator. In other words, like keep a few more decimals than just 2 decimals if I'm going to do that. And then I think somebody else said something I could do with 55 degrees. Is that what you said, Janet? Okay. So I could use this 55-degree angle here at the top, and I could use my y and my 8, and then what trig function would I be using? Sine. So there's lots of ways to do the problem, right? Okay, so I just want to make sure everybody's on the same page on that. But you don't have to be on the same page, basically, right? Yes. All right, one more application. This is really a much more applied problem than the last one, but just trying to get our feet a little bit wet with the last one. A radio transmission tower is 200 feet high. How long should a guy wire be if it is to be attached to the tower 10 feet from the top and is to make a 45-degree angle with the ground? So I need a picture because that's a lot of imagery. So it tells me I've got a 200 feet high tower. So over here is my 200 feet. Okay? So there's a 200-foot tall tower. It says that the guy wire is to be attached to the tower 10 feet from the top. So I'm not actually going to attach a wire at the top of this tower. It's 10 feet from the top. So maybe about right here. Okay? Which means that what's left here, let's do this, is 190. You got it. So this piece is actually going to be 190 tall now, right? I didn't get it quite on top there. But now I've actually got 190. It says that the guy wire is supposed to be attached at that point, and then it is going to go down to the ground and make a 45-degree angle. So here is the 45-degree angle. In construction, 90-degree angles, right? Except for the Leaning Tower of Pisa. Yeah, 90-degree angles. So that's why I put the 90-degree angle there in the corner. And that's why we're dealing with a right triangle as well. All right, and so we are supposed to find what? The length of the guy wire? How long should a guy wire be? Yep, that's right. So we are trying to find this length, and in math terms, what is that in this picture?
Hypotenuse.
It is the hypotenuse. So how am I going to relate this 45-degree angle, this 190 feet, because it's not the 200, right? The 190 feet, and this side x? That is sine. So what will that look like? Sine of what?
45 degrees.
Sine of 45 degrees equals 190 over x. Okay, how am I going to solve this for x? Multiply by x. So now I have x sine 45 degrees equals 190. And then what?
Divide by sine 45.
And then divide by sine of 45. Now 45 is one of our special trig values, right? So if you want to use that information, more power to you. You can, right? You don't need a calculator actually to find an exact value for this expression. However, the other issue with this is that this is an application problem. So if that sine of 45 has any square roots involved, which it does, you're going to have to use your calculator to simplify and find an expression that makes sense for an application answer as well, right? So you can just use your calculator as is with 190 over sine 45. And what is 190 over sine 45?
268.70.
And what units would we have on it? Feet. Does that seem reasonable?
We like just multiply it. Just curious. Could you just multiply it by the square root of 2? Like since we have that one.
Mm-hmm.
Oh, okay.
Yeah.
I didn't know that's what it was.
Yeah, so like if you had the 190 times square root of 2. Yeah, grab your calculator. What is 190 times square root of 2? Got a nod. Yeah, it's the 268.7, right? Absolutely. So you can use those special trig functions or special trig angles that we talked about, or you can use your calculator with the sine 45. But any way you do it, you're going to grab your calculator because you're going to have to give the answer with decimals for it to make sense as an application. Because if you go and you tell somebody that the guy wire needs to be 190 square root 2, they're going to look at you and say, what are you talking about, right? So you're going to have to give them that answer in terms of a decimal expression for it to make sense anyway. So either way, yes, you'll get the same answer. Any questions on that? All right.